Hi everyone, Geophysicist Stefan Burns here. We right now are in the midst of a solar storm impact. This is a pretty big one too. This was launched out on the 30th of July and now it's hitting us on August 2nd, 2026. And well, there's a whole bunch of interesting energetic interconnected characteristics with what's been happening with this solar activity and now geomagnetic activity and what is going to be occurring next year with the longest total solar eclipse of the century. And that peak eclipse will be over Luxor, the Valley of the King and Queens in Egypt. But that is for later in the video. We right now here on Earth have evidence that there are a number of very critical faults and also volcanoes, dangerous faults and volcanoes that are at critical stress or just in critical states, ready to go. We don't know when they're going to go, but they're certainly showing signs of increased activity. And well, when you get these sort of solar storm impacts and this plasma from the sun comes in, it charges up the entire planet more versus when it's just in quiescent conditions, you have the normal solar wind flowing by, which, yeah, there's always a solar input. Of course, you have also the light radiation of the sun. But these solar storm impacts charge up the Earth much more than normal. And that's what we are in right now. We can see that here with our real-time solar wind as provided by NOAA. And we see our solar storm impact coming right there very clearly. So we're around 4.36 nanotesla, about 4 to 5 nanotesla for the strength. Nanotesla is a measure of magnetic strength. Earth's magnetic field, for reference, on average is about 40,000 nanotesla. The range is 22,000 to 67,000. So mid-latitude zones typically around 40,000 nanotesla for the Earth, but that's just an average. So this is only coming in at 4 to 5 nanotesla, but the magnetic field for the Earth drops off in such a way that eventually it is at these strengths of 5 nanotesla, and that's the solar wind average. So that's where Earth's magnetic field and the solar wind meet. Well, when you get this thing to come in stronger, now it's at 14 right after impact, strengthened all the way up to 21.5 right there. Now it's pushing much further because the magnetic field of the Earth drops off with an inverse square law. So it really decreases quite significantly as you go out. Therefore, that's pushing the magnetopause, the boundary between the solar wind and the Earth, in much closer, and that crunches Earth's plasmasphere and causes the plasma that we already are holding on to in our magnetosphere, again, the plasmasphere, it precipitates that down into the Earth, into the ionosphere, which is also a plasma, but it's a weak plasma. This drives much stronger electric currents than normal, and as a result, you get geomagnetic storming. Because these electric currents in the ionosphere create these magnetic fields, which are very strong, which we then feel at the surface. This can cause issues like power grid outages, technological failures, cellular communication failures, radio blackouts, satellite issues, GPS issues for really strong ones. So this isn't a solar storm that's strong enough to really be concerned about that. But because of all the activity that we've been having recently, the earthquakes in Japan, the earthquake with Mexico, earthquakes with Venezuela, quite a bit of earthquakes around New Zealand. We're going to be talking about that. We've had distributed magnitude 5 earthquakes all across both the northern and southern island of New Zealand. So that's one of these critical zones. The Alpine Fault really hasn't had a big rupture since 1717. I mean, it's had big earthquakes. New Zealand's an active spot. It's also not that big. So when you get a clustering of magnitude 5s like that, all less than a month, with tons of activity to the north in the Kermadec Trench, it makes you pay attention. We also had, of course, this 4.7 magnitude earthquake that struck Campi Flegrei. That was quite significant. So this is all coming in. We see that we had this very strong connection here. This is really the key driver for whether a solar storm impact is significant as it relates to a geomagnetic storm, is whether you get this strong negative coupling, because Earth's positive field, solar wind has a negative field, let's say. If that happens, you get that energy injection very cleanly. That's exactly what happened. 21 nanoteslas, pretty strong. Now this bucket, as I call them here, did not last forever. We see this is going from 1415 UTC, let's say, to here, 1600. So an hour and 15 minutes. But if you look at this overall, we've been in this southward component territory for 1320 all the way to now, which is 1750. So a longer period of time. Solar wind density is high, so 20 particles per cubic centimeter is quite high for the density. So this is a slow and dense wall of plasma that's hitting us. We see the velocity there, only 412 kilometers per second. So again, slow, but faster than the solar wind was. Solar wind was under 300 kilometers per second. Now we're at 412. We went all the way up to 440 or so. But slow and dense with a strong magnetic connection. So this party is basically just getting started, and it takes time for this energy to work through the different geophysical layers until eventually it does reach these layers like the lithosphere where volcanoes and faults live. So there's no guarantee that we are going to see some sort of response from this, but fundamentally this energy is charging up the Earth more, the global electric circuit, and creating strong telluric currents, electric currents that flow through the ground surface, which have an influence, as we know with a ton of research, over faults, volcanoes, and more. So Again, it depends on a specific system and the critical stress that it's at and whether it's ready to get triggered, right? This acts as like a trigger mechanism, a loading and also a trigger mechanism at times if that critical state is there. And well, we know that there are a few systems at these critical states. So it's a heightened probability, there's a heightened risk right now that in August, we're going to see some big events. That's certainly possible. That's what I'm going to report on for you today. So hello and welcome everyone. I'm your host, Stefan Burns. That's spelled S-T-E-F-A-N. You can see that on my handle. It's not spelled differently. Just as a quick aside, it's not spelled any other way. It's S-T-E-F-A-N. Thank you so much. I cover what's happening here on Earth energetically with earthquakes, volcanoes, severe weather, and geomagnetic storming. Also, we've had tons of wildfires. We'll be talking about that today's video. We also cover, of course, solar activity, space weather, planetary alignments, and planetary geometry, planetary resonances in general, interstellar cosmic forces, consciousness, and more. If you like the sound of that, then please subscribe. Thank you so much. Let us look at what's been happening with the solar storm. What precipitated this solar storm? And then we'll look at the magnetic fluctuations that are occurring right now. So here we see our coronagraph view. And I put out a forecast for there to be enhanced space weather and solar activity right around the end of July and beginning of August as a result of planetary geometry. That work goes back almost 100 years now, perhaps even longer, but really J.H. Nelson, if you want to, you can check him out, J.H. Nelson at the RCA Corp. Goes back quite a way. I use that method as well, expanded upon it a little bit now with some more modern understandings, and put out a forecast on May 27th for there to be enhanced space weather solar activity. Well, we had this Sundiver comet, pretty unusual, just kind of come out of nowhere. We get them, but you know, it's notable. And then seemingly right when it hits the sun, right, it would have turned into superheated plasma and then been routed down the magnetic field lines to an area of disturbance. These sunspots are actual magnetic vortices, right? So it's going to swirl it right in. That is a hypothesis, at least. We see, though, that right around the time that it impacts, you get this big coronal mass ejection launched from a long duration 1.9 M-class flare, the second strongest category of solar flare. So this was from 60 degrees longitude to the west solar coordinate system, yet even then it's kind of unusually redirected itself to Earth. We see that nice halo coronal mass ejection coming out. And here we see the coronal shock wave from that. So see it propagate out like this. That's the location. That's sunspot group 4492. A nice coronal shock wave. We're now being hit by that. So that forecast is put out on the 30th because that's when it happened. the long-range forecast being put out on May 27th of this year, 2026. And interesting enough, this solar flare right here triggered the first S1 radiation storm that we've had, a significant radiation storm, the first one since May 26th of 2026. So one day after that last radiation storm, I put out my long-range forecast, and then that forecast accurately forecasted this one. So a synchronicity right there for you. But all this is speaking to, in many ways, a larger story of what's going to be playing out over the next year, because we have this very significant total solar eclipse that's hitting, well, most of Europe and Africa. They'll be seeing partial parts, but really centered directly over Egypt. That is, a huge energy site for civilization and more, with the Valley of the King and Queens. Many temples there. I've been there. It's really quite remarkable. That's August 2nd of 2027. And so some pretty interesting things energetically beyond this were occurring right at the end of July. And right now, today is the 1 year pre-versary, you could say, of this total solar eclipse that's going to hit Egypt. And so I think we're seeing some of the initial energetic buildup for that. So we'll get into that more, but I want to show you this magnetic field map here. Here we can see magnetic fluctuations that are occurring as a result of this impact. So it doesn't start off like an instant huge jolt hit, but within about an hour and a half, you start to see it really start to increase there. And you notice that the magnetic field fluctuations are concentrated in strength in the polar regions, because that's where the solar plasma gets funneled down. So it starts off slow, but you do within about an hour start to get this really increase. And here's dark red up here. This is 400 nanotesla, and often a geomagnetic storm will send the magnetic field swings way above 400 nanotesla to 1,000, 1,200, 1,500. You can even go to like 2,000 plus nanotesla. That's a really strong storm. So this right now is a notable impact, but we're not at technically G1 levels for a 3-hour measure, though maybe that just came in. But we do see that our magnetic activity is going up quite quickly. We can check that out with our HP30 and HP60 indices, and here they are. And well, look right here, right behind me, here is our impact. So coming in right around 1200 UTC, quickly spiking up to near G1 levels, 5. A KP or HP index value of 5 is a G1 storm, which is a minor storm. Then you have a G2 storm, that's a moderate storm. G3 is strong. G4 is severe, and G5 is extreme, and G5 would be a 9, so it goes down like that. Well, we did spike up in our 30-minute measure to a G2 plus level right there with that value of 6.33. So this has quickly ramped up, but it has effectively just started. And typically these storms last for more than just an hour or two. So we're probably looking at another 12 hours of at least strong solar wind, and then eventually it may die down. But often what you get at the beginning is actually not the strongest part of the storm. We could see it increase even further from here. But we're looking almost certainly at G1. I think when this averages out, it's going to be a G1 storm for the next 3 hours. We're looking at G1 storm, probably G2 levels, and if it continues to stay strong, then it'll be a G3 storm. That's certainly possible. And so you start to get to that strong level, even stronger electric fields, because the way it scales, it's not linear. G1 is not just like 2 bumps up to G3. It scales kind of like this. So G5, extreme storm, is really strong, like really, really crazy. So, going from G1 to G2 to G3 is actually quite significant, and we could be seeing G3 activity from this. I think we're going to be seeing G2 and maybe even a touch of G3 activity from this. That was my initial forecast when I saw that coronal mass ejection, because we had this proton storm here. So here is our proton flux, our high energy proton flux, measured in mega electron volts. And we see that even our green and blue lines bumped up. So those are even higher energy protons. And our red line reached that warning threshold, but when you get the harder spectra to bump up, you very quickly get to a radiation storm. Now it's basically back to normal. So this is over, but we've already been charged up as a result of this, okay? So this energy is already coming into the polar regions, and as you may recall with my video 2 days ago, here we see this jolt that hit Campi Flegrei, Pozzuoli, outside of Naples in Italy, okay? That was from the 4.7 magnitude earthquake that struck. So that happened during this radiation storm. Now, it probably would have happened regardless of the radiation storm, but these sort of space weather influences just charge this stuff up even more. And you can see some of the building damage here. This is just one little preview. I mean, there's actually a lot of damage caused by that 4.7 magnitude earthquake that struck Campi Flegrei, Italy's super volcano. Europe's big problem, basically. But that's a big jolt. Peak acceleration with that was almost equivalent to the force of Earth's gravity. So just like, boom, hit, knocked a lot of stuff over. A lot of these buildings, because they've been having earthquake bursts and swarms at Campi Flegrei because of the volcano and Brady seism and everything, a lot of them are actually already like just basically held in place by hope and a little bit of dust and friction. Because earthquakes have been battering magnitude 4.4s, 4.6s, 4.2s, etc. So this 4.7 coming in with that really strong jolt caused quite a bit of damage to some of these older buildings that are already at the end of the end, let's call it. And so we have, you know, for example, Campi Flegrei having been activated during this time frame with the strongest ever earthquake right outside Solfatara, bit of a sign that, you know, this could be building up to something even bigger, perhaps even its next eruption. The last one was Monte Nuevo in 1538. And so it's been like 500 years, but we're seeing increasing activity just across the board with Campi Flegrei. And there are other locations as well to be worried about. I want to show you now New Zealand, because New Zealand's really been kind of making a name for itself over the past month or so. New Zealand being a very active place seismically, of course. It's not nearly as active as Japan, though, which is like one of the most, if not the most, active spots geophysically on Earth, especially with earthquakes. But they have tons of big volcanoes there as well and such. But if you look here, we just had a 5.6 earthquake strike to the north there, and it did strike the island. So it wasn't off the coast, it was right there. But that 5.6 being at 52.8 kilometers, pretty deep, not too big of a deal. Not that populated out there. But then let's say we look at our largest magnitude quakes. We see that we had this 5.7 on the 24th of July right here, strike also North Island, but right in the center basically. That was felt more strongly. And then we had this 5.9 down there on the 16th of July. So just in the past 2 weeks or so, we've had a 5.9, a 5.7, and a 5.6 across the islands of New Zealand, and also propagating northwards like this. You also see this clear frequency drop, right? It's very clearly going 5.9, 5.7, 5.6. With some smaller earthquakes in between at various dates. Here's an aftershock there, 4.8. That was yesterday on the 1st of August, showing a reactivation of that point. Here is a 5.0 that occurred on the 16th. And so that was just the same day as this 5.9, also giving a bit of indication that this entire area is starting to move more, right? So there's some energetic flow going across this entire area of New Zealand. To have 3 magnitude 5 earthquakes, 5+ earthquakes strike in 2 weeks is concerning, I would say, especially with all the activity that we've been having up here. Tons of activity in the Kermadec Trench, spread out too, like multiple seismic bursts that have been occurring. Here we see 5.9, 5.8, 5.2, like, you know, that's significant. And sometimes it's just kind of spread out all over like we see here. But we even have this volcanic node that's being activated with all these low magnitude 5s and high magnitude 4s. You see that that is a volcanic node because look at all the seamounts that are coming here. Okay, and so that's interesting to point out. A lot of activity here further off in the subduction zone, but all this basically is shooting energy towards New Zealand all the time. And now we're finally seeing a lot of activity with New Zealand in general. And the last big full rupture of the Alpine Fault was in 1717. And they can have up to a magnitude 8 or maybe like 8.1, 8.2. Like that's the current consensus, is that this is capable of megaquakes. So imagine a magnitude 8 just ripping that thing apart, right? Well, generally with the biggest earthquakes, you see some preliminary activity to them. And to put this into context, right, I talk about California quite a lot on the channel, being from California, and a lot of people are curious about California, big ones in California, etc., right? New Zealand, California, and Japan are all about the same size, okay? And they are all pretty active seismically. So imagine what would be happening in the news if we had a 5.9, 5.7, and 5.6 earthquake strike California all within 2 weeks, right? People would be pretty concerned. People were concerned already just with the 5.6 that struck on the 24th of June. And then also these earthquakes that struck here at the junction of the Garlock Fault and San Andreas, and then further along the Garlock Fault. We were talking about those, you know, people, there's warning signs or just indications of kind of the changing distribution of stress and perhaps what's next to go anywhere you look. So, but if you were to have all of a sudden a 5.9, 5.7, 5.6 all strike in 2 weeks, like that would really be a sign that, okay, probably something bigger is coming. And so we only have 3 million Kiwis and beautiful people living in New Zealand, but you know, applying that same mindset, well, this is definitely something to be mindful of if you live here, or if you're planning on taking a trip here. Just in general, be prepared, get ready, because this is very distributed, showing that there is an initial release of stress across the entire microcontinent. You know, this used to be, this is effectively an old continent now, but it's a lot of it's submerged and now it's being split in half, etc. But there's a lot of residual, well, not residual, there's a lot of activity right now. And the question is this preliminary, showing that it's just some initial fracturing before a big one? Because a 5.9 compared to a magnitude 7.2, let's say, is nothing. Energetically, it's like nothing. It's a drop, it's like 2% or less of the magnitude 7.2 in this example, right? Or is this actually the release of energy that then things are going to quiet down afterwards? That's certainly a possibility. Maybe it's actually the majority probability. But this is the sort of activity that we look for. These aren't just like magnitude 2s or 4s or 3s or whatever. These are getting close to magnitude 6. I mean, this 5.9 here, right there in that critical zone too, near the Alpine Fault. And these are a little bit deeper too. If you notice, they're a bit deeper. So that's kind of indicating this energy coming up from depth. So yeah, I mean here 76.4, 52.8, this 5.7 they put at 10 kilometers. And then this 5.0 there, also 10. But we see some other deep earthquakes with our magnitude 4s. So I'm looking at New Zealand very closely as a result of that. I think we should be very mindful of that. Now, if we go to our coronagraph view, I want to show you something cool. We're going to look at our C3 coronagraph here. Coronagraph shows us the solar wind outflows from the sun and more. And we will get this going. So here is our C3 coronagraph for the past 24 hours. We don't see anything super notable launching out from the sun during this time frame. The solar storm that we're having right now is the big thing. As of right now, we don't have anything following up behind it. But see this bright point of light there? That is Jupiter. Jupiter there has just performed its superior conjunction with the sun. Does this about every 13 months. So it was, came into view like this, and then it went behind the sun. It was right there on the 29th of July. The 30th of July, it started to move off, and here it is today, the 2nd of August. So if we go back to our coronagraph view here, you'll see that we don't see Jupiter because it's like basically right here at this moment in time. So the point of me mentioning this is that we had this solar storm, this solar flare, the Sundiver comet, the solar flare, and the solar storm all happened while Jupiter was cazimi with its superior conjunction. So A, that's indicating a connection to this next Jupiter cycle, the synodic cycle of Jupiter and the Sun, which is again 13 months in length. And B, it's also indicating that that point, that alignment of energy in our solar system out to the constellation, you could say, is notable. It's important. So that, again, was right there on the 30th of July. And now we have this happening on the 2nd of August, this solar storm impact with the geomagnetic storm and more. Well, next year on the 2nd of August, we have this total solar eclipse over Egypt. So we can see that right here. This is quite significant. Here is the path for that total solar eclipse. And the shaded black area is the path of totality. So there will be partial eclipse off on either side. But you will see that total solar eclipse is a very special moment if you are exactly in that path. And you see it passing right there through Gibraltar, through all of northern Africa, slicing down through Egypt, Valley of the King and Queens, right there, and then in Luxor, and then sweeping through past Yemen and Somalia, and then it goes further out into the Indian Ocean. We can also look at it here with this graphic by NASA, which shows it a little bit more clearly, but it's a little, not as high resolution or nice looking. But there is where it begins, goes like this, and then it sweeps out. I believe that's the direction. It is possible that it goes the other way, but I'm pretty sure it's going that direction. So this is kind of really implicating all of Europe and Africa for this eclipse. We have a total solar eclipse that's striking Australia in 2028. That's going to be the only total solar eclipse that they get in, like, if I'm correct, in like 800 years or something. Like, it's kind of bizarre. Typically, it's not that long of a duration in between them. So, these are energetic, important energetic moments in time. This one being centered directly over Luxor. Directly over Luxor, with the Valley of the King and Queens, which basically is some of the oldest history that we have. Especially when it comes to them having very clear ideas of spirit and our place with the universe and the afterlife and what happens to our spirit and more. And we're really just scratching the surface of our understanding of what they actually believe. They have a lot of elaborate religious ceremonies where they use plant medicines to effectively just kind of blast themselves off into space. And well, what was happening in space? Well, right when we had this solar storm launch off, right here on the 30th of July, during this cazimi, we see that Jupiter is in alignment with Cancer, the constellation of Cancer. So is the sun, okay? That's it right there. So this is the position of the Earth, the sun, on the 30th of July, and now it's the 2nd of July, 2nd of August, and this is where we are for the impact. So clearly that window, this cazimi window, is important. Well, let's go forward to 2027, to the 2nd of August. Here it is. And that is our total solar eclipse, okay? Because you see the moon right there in front, right? You see the moon in front of the Earth. And if we actually want to be really precise, it's going to be, I guess you kind of have to get the timing on this correctly. I guess it's going to be kind of right about there. We go back, go like this. Okay, so it looks like the eclipse is going the other direction, but see the movement of the Earth, right? See that rotation? That's going to be, it looks like, basically the exact moment of this eclipse. So we have that happening in the same constellation, right? Smack dab, same spot, etc. Now Jupiter, though, is in the constellation of Leo, and it's conjunct Regulus right here, right? And Leo is the Sphinx, right? The Sphinx and Leo are one and the same, and Regulus is the really important fixed star of royalty and of kings and pharaohs and more. And there's some of these prophecies about when Regulus rises over the Sphinx and the world's going to whatever, and but there's a lot of important symbologic archetypal energy and just overall history with Leo, the constellation of Leo, and the fixed star of Regulus. We also see that it's conjunct Ceres there. Our dwarf planet in the asteroid belt Ceres is also in that alignment too. So this is, I think, really hinting to the fact that this upcoming total solar eclipse that's going to be peaking like 6 minutes of totality. Again, the longest duration of totality for the entire 21st century by a wide margin over Luxor is going to be significant. So we're already seeing signs that this is the case. And we even see here also a Pluto, Earth, Sun, Venus alignment there. And we just got out of this Jupiter, Sun, Earth, Pluto alignment. So now we have one that's a little bit of a different flavor, but still involving Pluto. Pluto is going to be roughly in the same position as the sky as well because it moves very slowly. So there's a lot of things here that are very interesting, and we have that coming up. But before we have that coming up, we actually have a solar eclipse coming up over Northern Europe. So this is the eclipse path that we have for August 12th. This is a total solar eclipse as well, but this time, the sun, moon, well, the Earth, Moon, Sun alignment is going to be more in between the constellations of Cancer and Leo. So it's almost like this is kind of a little bit of a halfway point in between what's happening now and what's happening next year. Because we did have our full moon, of course, on the 29th, and that is now leading into this total solar eclipse. That's the next phase of the moon. And we see it sweeping there from over the Siberian area for Russia, past Greenland, then hitting the western fjordlands of New Zealand, and then sweeping through Spain and going over some of the islands there off the coast of Spain. I think it's La Palma, Ibiza, and there's one other one. So maybe Majorca or something. No, that's Greek. So this is what we have coming up next energetically, and we're leading into this now with this solar storm. These solar storm influences, like a geomagnetic storm, there is some research showing that as it relates to earthquake activity, you can kind of expect there to be an increase in seismicity about one lunar cycle after the impact, about 28 days, a month or so. So sometimes we see big activity coming like during or right after the storm. That seems to suggest that they're connected together because, I mean, we've had it before where it's like a big G4 storm comes in and then boom, you get a magnitude, like a high magnitude 7 earthquake, and it's like, okay, I mean, maybe it's coincidence, but it's the timing. You can find other little timing cues and everything, so it seems pretty much, at least to me, that they're connected in a more instantaneous way. But there is research showing that as this energy moves through the different geophysical layers of the Earth, the magnetosphere, plastosphere, ionosphere, atmosphere, lithosphere, into the oceans as well. It's a whole bunch of phenomena we don't understand. Green glow is observed over Hawaii recently. People are still confused over that. These flashes of light from the deep ocean have been observed for centuries, if not millennia, by seafaring tribes and like Polynesia and stuff. And we don't know what that is, like electrical discharges of the ocean. Like we don't know. Maybe it's a bioluminescent phenomena. That's all still plasma though, right? So we could be looking at later in August there being an increase in activity. Just in general, because we're having this versus not having this, I think we're looking at some bigger activity now for August. So of course we've already had big activity, and that's kind of the other thing. We've already been seeing a lot of activity. And the way it kind of works is, unless you have that die out and things go quiet, it kind of just begets more big activity, because the energetic waves are propagating out and they kind of load up other faults and systems, and then they start to go off, and if they have a lot of stress that's been built up, they set off other things. So it's a domino effect. And it just takes there to be a point where you set off enough of these, let's say, faults, that all of them are more at their loading phase rather than at their rupture phase, their critical stress phase, that they then absorb that energy, and let's say you don't really get too much solar activity to add more in, and then things can finally quiet down. So we're definitely in a very active period right now. That is what is happening. And in addition to that, we've had tremendous wildfires across the world over the past couple weeks, more than that I want to highlight. So this has been a pretty big deal. Here we see the wildfire smoke intensity over France and the Iberian Peninsula for July, because they had, of course, huge heat waves, and there's been massive droughts all across here. You can see the browning in real time. See that? Massive heat records have been broken for France, for the UK, since all this began. Like, never before have there been such high temperatures for such a long duration with our modern historic records, okay? Now, some climate people are taking that data and extrapolating it out to like 120,000 years and stating this is the strongest it's ever been for like 100,000 years. And that's simply just hogwash, because, well, we don't really have high resolution records for 50,000 years ago. We know that there are ice ages, but there were also interglacial periods too. So it's possible. We've seen things like this before, but not in the modern time frame whatsoever. And we had fires that are creeping in and basically getting really close to Bordeaux. Just big fires overall in Western Europe. We've also been having fires in Greece and other locations that have been quite significant. 2 helicopters just crashed together in Greece. These wildfire fighting helicopters, just really quite an intense video. I don't really want to show it to you. I'd have to pull it up, but it's a little too much maybe for some people. But here we see our wildfire map for the United States and just in general North America. We've been having tons of wildfires. In fact, we right now have this, I think it's the Old Trails fire, which is basically encroaching upon Spokane, Washington. It's already been burning down dozens and dozens of homes, if not hundreds now. I mean, it's been a very strong fire. This is saying 2,500 acres, but some recent estimate I saw showed 3,500 acres. It has very low containment. But you can just see the wildfire smoke coming in from all these locations, right? They do their best to color in the location here, but this is not real time. And these little labels there, are just basically cueing you into something. But you can see a lot more clearly the wildfire smoke with this data here. So the actual live satellite data. So look at all that smoke going out, and if we go forward, let's turn on our live satellite, not our HD, because you can see this smoke spreading out. If you go back in time, look at this. So we go back, maybe use our 1 hour view here. Look at, right here. Look at this. Look at all the wildfire smoke across the western part of the United States. Just huge, huge, huge fires. And so that's all going to be affecting also then, of course, the weather of the U.S. People heard about, of course, the big fires in Canada. They were sending tons of smoke down over the Great Lakes and into the eastern seaboard. That was further back. But there's just been, the weather's been really crazy. It's been really hot, really dry. The super El Nino is getting very, very intense. Where I am, we have very warm waters off the coast. So we're seeing the potential for hurricanes basically to travel up the coast if they want to. We've been seeing them a little further out like this. This is Hurricane Genevieve reached a Category 5 status there on the 26th of July. Just in general, with these other systems, things, as we can tell, are very, very active and volatile. And they all connect together to varying degrees, right? So when there's a lot of activity in these spheres, that also just kind of begets, to some degree, not the greatest, but to some degree, more activity in these other spheres, which are a little bit more Earth-related, like deep Earth-related, like the earthquakes and volcanoes. But we know that atmospheric circulation has an effect on the angular momentum of the Earth itself, which can change the time of length of day. And that these changes to the angular momentum influence something known as the Chandler wobble, a 433-day, roughly, nutation or wobble of the Earth, at maximum about 10 meters of wobble. So it's a pretty minor thing, but we had the Chandler wobble disappear effectively back in the 2010s. It's starting to come back, but it's still not full strength. And if you look at earthquake records, there, and you do like a power spectral density plot of them, and you look at the periodicity that emerges, you'll see like solar cycles, like an 11-year periodicity. You'll also see a 430-ish day periodicity. You'll see that Chandler wobble signal pop out. So it's not that the Chandler wobble sets off every single earthquake, but there is this connection there. So it's important to track this stuff as well, like the atmospherics, because this does influence everything else. So it's not the biggest influence or the most obvious, like some things that we cover here are, like the solar activity, which is much more obvious in many ways, but it's worth pointing out. And a lot of people are actually being affected by this. So, our thoughts and prayers go out to everyone that's been affected by these wildfires across Europe, across the United States, North America in general, and many other locations in the globe too that have been battling pretty strong wildfires this season, as this is the year with the, according to our modern records, again, our modern records, the hottest year ever that we've observed, with sea surface temperatures being the hottest, and just in general, it's been a very hot year. The interesting polarity to that is that it's been a very cold year in Antarctica. So that's a good sign, you could say. It has been a very cold year for Antarctica. So the bigger picture, as I've said many times now, it's not just a linear trend of global warming, though we do see the Earth warming up. More important in my mind is we're seeing increased volatility with the weather. And this is driving Earth electrification. And there's more than just that too. Another thing to point out, and maybe we can actually pull it up here in real time. Let's do this. I think, how do I turn off the weather, or the, there's a way to turn off the fire alerts. I remember it took me forever to find out how to turn them on, but I don't really want them now. But we saw interesting cloud formations over Japan and also over Campi Flegrei during their earthquakes. So here we have Naples. We have to go back to the 30th to see the earthquake that struck. Okay, so maybe this will give us a good enough view. I'm not sure how far, I think it was a little bit further to the north that this occurred. But we'll see this big like anvil cloud form very quickly. If you can find it. Maybe that was it right there. Let's go forward to the next day too. Because these weather effects that I'm mentioning, they've been lasting longer than just the day of. We've been having these interesting cloud formations over Japan and over Italy. Yeah, so here, yeah, there it is. See that? See that that anvil cloud form? Just like settling out of nowhere. Now that will happen, okay? It's not like this cloud formation is impossible or something. But the point is that when you get these earthquakes, you get this positive charge to build up. And that positive charge specifically accumulates in higher elevation locations like hills and mountains. And so you just go slightly to the north there, right, where you have the mountains, and then you see this big cloud form, right? And what's driving a lot of that is the electromagnetic dynamics, the stronger conductive flow going from the ionosphere to the ground surface, vice versa. That can all drive cloud formation and more. So we saw this here within 24 hours of the 4.7, and earthquake swarm, mind you, is continuing in Campi Flegrei, 200 plus events now. We also saw this in Japan following their big earthquake. So we go over to Japan. I hope it goes far enough back. Let's see how many days we can go back. Okay. So now the earthquake in Japan, I believe it was the 26th. Let's just confirm. Sorry, 28th. Okay, so that's good to know. So let's go back now. So now we know that we want to look in at the 28th of July, and there was this, where specifically was this anvil cloud? We should be able to find it because it occurred at the same time. Now the earthquake occurred right in this area here. So maybe I need to zoom in more. Let's see what pops up. There it is. Ha! Look at that. Look at that. Just out of nowhere. Okay, and well, that occurred simultaneous basically with that earthquake. Well, look at the location. You notice the topography here, right? There's mountains. You have this big magnitude 7.1 strike, a positive charge, and this in fact happened more than just once. Then directly afterwards, like less than 24 hours later, there were really strong winds, basically like these microbursts that hit more in this area of Japan here. They've been having really strong weather. So the larger dynamics here is, for example, the electric field, how these rocks can hold on. They have all this strain placed upon them. They generate the reverse piezoelectric effect, or the piezoelectric effect rather, of where the strain generates these electric signals or these charges, can build this larger positive electric field at the ground surface, going from depth to the ground surface, extending up through the atmosphere, going up to the ionosphere, altering the plasma properties of the ionosphere, and that's going to alter the local weather. And so there's enough like little things like this to point at basically that indicate that there are some pretty powerful energies that are being liberated from within the Earth into our more human domain right now at this time, and this solar storm impact is going to be feeding all that, right? Because this energy, with the way it eventually gets to the ionosphere, induces energy into the crust and the mantle of the Earth directly. Doesn't need to go through the atmosphere. A little bit does, but most of it actually just gets directly induced into the Earth. So think about, for example, if you have an induction stove, right? The way that works is you have this magnetic field that gets generated by the cooktop, and then you have your pan that maybe has a copper core, let's say, or something conductive. Often it's like aluminum now, whatever. You put that on top, it's now inducing what are known as eddy currents within the pan such that it heats up and now you can cook your food. Well, you could even hold that pan up a little bit above the surface. If it, you know, these stoves basically turn off if they don't detect the pan. But if you could turn that off, you could hold the pan up and there could be air in between and you could still get the pan to be hot because the magnetic field doesn't care about an extra inch, really. I mean, it decays a little bit, but you can get that induction. It's the same principle here. You know, that inch is the atmosphere and then everything else is where the energy is really active. So we're having, you know, induction of powerful electric currents occur during these sort of solar storm impacts. Let's go back to our real-time solar wind observations, see where we are, and then we will get into a very quick question and answer, see what's happening, and then I'm going to sign off. So hello and welcome everyone Yeah, okay, so aluminum doesn't work with induction, but like copper and steel do. Typically, you want like a good copper core to them, but they may use aluminum as other parts. So some super thanks have come in from Mona Two Cats. Is total seismicity graph volcanism inclusive? I don't know what you mean by that. I'm sorry, but thank you for the super thanks. Nierka, thank you for the super thanks. And Texas Even Star, thank you so much. You've been a supporter before, so thank you again for that. And Dave, hi Stefan, I grow beyond organic food for Food Bank UK. I've increased growth using electric. Do you think plants greening is not just CO2? Yeah, I mean, planets greening, maybe you mean planets greening. But plants in general, you know, they like more CO2. It's more complicated than just more CO2 is good for plants. It's trust me, it's a more complicated thing than just that narrative which people latch onto for being anti-global warming. But the planet greening overall is a good thing. It's probably because there's more water, honestly, and around the Earth. Think of the ice ages, okay? So we can, you know, talk about the ice ages, and well, a lot of that fresh water was locked up in ice sheets, right? Big ice sheets. So outside of the ice sheet regions, it was generally a lot more dry. You had a lot less water in the hydrosphere overall. So you could still, there was still going to be some tropical locations, like right there in the equator. That's really where we should be looking for like ice age civilizations, perhaps. But in general, it's very, very dry on Earth. And well, plants like water, of course. So the fact that when we burn hydrocarbons releases water, it's not just CO2, it's also a lot of water, is probably one of the key factors as it relates to the greening. But as you can tell, you know, you get some droughts to roll through, weather's more volatile, that can cause everything to die off really, really quickly, and then you get the fires and more. And well, that will lead to a new cycle of growth because the Earth likes to fertilize herself with the ash and more from these fires. But yeah, we're entering into really a new era as I see it with the Earth. So thank you for your super thanks. Amanda, thank you for your super thanks. And Geraldine, thank you for your super thanks. It is very much appreciated. We'll look at the regular chat to see what we got here, and then I am going to sign off. Here is a good comment from Mikam. Cloud Ionosphere, look up Demeter satellite program. Yeah, a ton of fantastic research. Well, just in general, connections were elucidated by the Demeter satellite program. So that was running in the early 2000s, and it was a satellite that ran through a lower part of Earth's atmosphere. So it was pretty close into the surface. It wasn't like way out geosynchronous or anything. But it was there for a good length of time, like 6-8 years, something like that. I think it was 2004 to 2010, but don't quote me on that. And it was there for a bunch of solar storm impacts, and it picked in a lot of earthquake activity. So a lot of really interesting connections were made with these different layers I've been talking about via the Demeter satellite program. So thank you for that super thanks. N8IM, thank you for the kind words there. And some sage advice here from Willow. Interesting question from Worms Tree Care. Hey Stefan, my buddy asked me, do you know why your solar system is on a single plane, and is this common among solar systems? It's likely as a result of how the gas, dust, and plasma, it's all going to be a weak plasma, basically, of this protostellar, protoplanetary disk, how it's all going to come together. We just see in general, fractally, that things tend to kind of flatten out. I mean, we see with our galaxy, there are some like spurs and offshoots, but it tends to kind of flatten out. probably as a result of like magnetohydrodynamic processes and gravitational attraction, bringing it all together, right? But we don't exactly know why. And is that common? Well, I mean, we do see in our solar system a lot of trans-Neptunian objects have very inclined orbits. With other star and planetary systems that we've seen, it appears that they roughly are on the same plane as well. But I don't really have a good answer for you. I'm sure there's other systems out there where the planets are more inclined, but I think to reach things are very dynamic. It's a dynamical system. But for you to reach a stable dynamical system, you probably need things to be a bit flatter than inclined. Mercury's inclined, it's small though. Pluto's inclined, it's quite tiny, but the other planets are generally pretty close to the ecliptic plane and also the solar equatorial plane. So you get too much inclination and it probably just isn't able to hold itself together. That'd be kind of my hunch. But it's a simple question that goes really, really deep. So I'll do more research into that because I don't really have like the best conclusive answer for you, nor may I get one. Because again, simple question that goes quite deep. Question from Jeffrey Swanson. What do you think the most critical fault in the world is right now? Do you think we'll be finding lots of new faults in coming times? Most critical fault in the world right now. Well, I mean, there's a few ways to define critical. Critical as in like the overall size of the rupture, like the magnitude. Critical as in the length. Critical as in the expected damage, like the actual human impact for buildings and people being injured and dying and more. I do think I have an answer for you now that I've had a few seconds to think about it. Let me pull up the location. Maybe some of you can guess. It's not California, but it is California. So here we have Google Earth. I'm going to turn you off now. Thank you for the question. And I really think it's probably Cascadia, because we can get magnitude 9s here. There's not too many places that we know of on Earth that do magnitude 9s. So we can have magnitude 9s in this location, or you can get a sequence of high magnitude 8s, which would be also super destructive. But with a magnitude 9, we're talking 5-10 minutes of intense, like the most extreme ground shaking possible. And there's also research that's been done where they were doing drilling off the coast, and some guy accidentally plugged in the wrong coordinates, and it took them further down here to like the triple point, and they found out that these offshore sediment sequences were very, very, very similar between Cascadia and the San Andreas, and in fact, it was suggesting that they simultaneously rupture at times. And we've seen this with other fault systems. So when you do get a big earthquake on Cascadia, eventually it's going to happen. When you do get a big earthquake here, let's say magnitude 8.9, say it pops off, God forbid, but let's say it happens, okay? There's a very high probability that San Andreas could then also rupture with, let's say, a mid to high magnitude 7, maybe even magnitude 8. A simultaneous rupture of the whole thing. Now, if the San Andreas, let's say, just had a big one 10 years before Cascadia, A, that would kind of be a preliminary, warning of that. But B, because it just had a giant earthquake, it's probably not going to rupture with Cascadia. At least the chance is going to be less because it's already done its big displacement, and only a little bit of movement and strain is going to be left. But as it stands right now, Cascadia is fully locked and loaded. San Andreas is fully locked and loaded. Cascadia is also fully locked and loaded. So if this was to go first, and this hasn't done anything significant since, like the last big 7.5 or greater earthquake was 1952 Kern County, right where the Garlock Fault, like basically right there, right? Before that, you have to go back to 1906 San Francisco, which ruptured the northern section. And before that, you go to 1857 Fort Tejon, which ruptured this middle southern section. This last southern bit hasn't been ruptured in a big way in like 200 plus years. But if this guy goes, if Cascadia pops off with a magnitude 9, I mean, huge activity all across British Columbia, Vancouver Island, Washington, you have Seattle, you have Portland, you're even going into eastern Washington with huge waves, so it's going to be reduced, for example, like for Spokane, going all through Oregon, Northern California, and then if you get that to follow up, let's say 2 hours later, it doesn't have to be 2 weeks later, it could be 2 hours later, it could be 20 minutes later, it could be 2 minutes later, then we could see that activity ripple out. And you know, magnitude 9 here is going to be felt, but not in a huge way, but it will be felt by people in the Bay Area, even probably further down. But one of the researchers who collected that sedimentary data off the coast, I just read an article on this, he was like, yeah, if we get a big earthquake to hit Cascadia, I'm jumping in my car and I'm driving east. Like, that's his new emergency preparedness plan. So of course, if everyone does that, no one's going to be able to leave because the highways will be all clogged up. But there is a lot of compelling evidence now suggesting that these simultaneous ruptures occur. So that's probably the most critical fault line in the world right now, in my opinion, because we've had Japan do the 9.1 in 2011, and also all these recent magnitude 7s. We've had Kamchatka do a big 8.8, but it's not that populated there, and they basically brushed it off no problem. I mean, you have like the North Anatolia Fault, which runs under Istanbul. That's a big deal, but it's not capable of magnitude 9. So you could get a really big one in Chile or Peru, like 1965, but not as populated, and they're pretty well prepared for it. But a big magnitude 9 Cascadia, maybe 9.2, like, I mean, it could get even higher. We don't really know. That, I think, is the most critical zone. So we will, yeah, and just to follow up, as I said, though, Istanbul doesn't need a magnitude 9 to be catastrophic. It could be a magnitude 7.3, and that could be really big. So there's multiple locations on the globe. But from what you kind of were saying, in terms of the size of the rupture, the overall magnitude, and the effect on people, infrastructure, animals, plants, the environment overall, I think Cascadia is the big zone. But there are others, like I just mentioned with the North Anatolia Fault as a good example. New Zealand, with its Alpine Fault, as we discussed quite a lot earlier in this video, is a big location. And there are plenty in Indonesia and the Philippines and more. So yeah. So that is what's happening right now. We have this solar storm impact coming in. There are quite a few locations that seem to be in critical states. Cape Flegrei, New Zealand. We've been having tons of activity with Japan already. California seems, you know, it's locked and loaded, ready to go. We've been seeing some preliminary activity there, it seems. So lots of places now. We'll have to wait and see how they resonate with this incoming solar energy, if they do or don't, but I will keep track of all this for you. I'll be live with updates if something big happens, as I do, like we're doing right now. So thank you all so much for watching, everyone. I've been your host, Stefan Burns. Please smash that thumbs up button to help the channel grow. Subscribe to stay up to date on what is happening with the Earth energetically. I release videos almost daily. And a big shout out and thanks to everyone here, the community that has helped this channel grow. I'm half the equation with the effort I put in. You guys are the other half, and we are getting close to 800,000 subscribers, which if you had told me that a couple years ago, 3 years ago, I'd be like, you're out of your mind. So much love. Thanks to all of you. Wishing each and every single one of you well. Have a great Sunday, and I'll see you all in the next video.